As fans, we often get frustrated when our team loses. It's natural to blame someone, often the coach. We ask questions such as, why the hell does coach play player X there? This is an elegant case study for an Olympic year. We need think back no further than the last Olympics in Beijing 2008 for an illustration. The example? In relays, the traditional sequence of runners in a team is picked from slowest to fastest. Selectors of the Jamaican men's 4x100 metre relay team confronted this very conundrum. Jamaica faced some hot opposition. Fortunately for them, Great Britain was disqualified in their semi, while USA dropped the baton in theirs, leaving Caribbean rivals Trinidad and Tobago qualifying first for the final by 5/100ths of a second. But Jamaica was still hot favourites for gold because they had an ace up their sleeve, with Usain Bolt, missing in the semi, to come back into the lineup for the final. But where? In what position? He was selected in the third leg, begging the question why, since he was clearly faster than Asafa Powell, who was picked as anchor, the final leg. The boring answer is that analysts will talk about how Bolt was a 200 metre specialist earlier in his career, giving him more experience at running the bends. The more interesting, that is, economic answer, applicable to all sorts of similar problems in many industries, is based on the distinction between absolute and comparative advantage. In its purest form, it's used as a means of explaining why countries engage in trade of goods and services, leaving everybody better off. Let us imagine that this grid outlines times selectors expect both to run their splits. From this, it is clear that Bolt has the absolute advantage over Powell in either position. But since there is only one Usain, not four, you can only run him in one position. So which? In short, comparative advantage tells us in which position Bolt should run. Note also from the grid that both run the straight quicker than either runs the bend, which my experience in athletics some time back tells me is completely logical. Anyway, how to work this out? That old economic chestnut, opportunity cost, defined simply as best opportunity foregone. Now, if we run Bolt in third, we obtain a time from him of 9.74. But in doing so, we forego running him as anchor. Hence, subtract 9.65 from this, leaving us with 9/100ths of a second. Using the same logic, the opportunity cost of running Powell in third is 12/100ths of a second. The objective is to minimise opportunity cost. Ultimately, it is a cost. And so, select the runner with the lower opportunity cost in that position. Conclusion, run Bolt in the third leg. But that's not quite the end of the story. We need to know that the true also works in reverse. Contrapositively to before, running Bolt as anchor produces 9.65, but imposes foregoing 9.74, leaving an opportunity cost of negative 0.09 seconds. And via equivalent reasoning, negative 0.12 seconds is the opportunity cost of Powell as anchor. Conclusion, run Powell in the anchor leg. This story has a happy ending. Jamaica won the final, astonishingly by almost a full second, and smashing the 15-year-old world record in the process. A tour de force of rational economic decision-making in sprint team selections.